So last time, my dear students, we had done with the electrochemistry. In the electrochemistry, we did the electrode or half cell. The second thing we had done, that is the electrode potential. Okay. So today we are going to start with the next third thing, that is the SHE. So SHE. So this is called as the standard hydrogen electrode. Okay. So SHE, S for standard, H for hydrogen, E for electrode. So standard hydrogen electrode, that is called as the SHE. Normally, my dear, I told you earlier that whenever you want to find out the potential, so the potential is always present between the 2 points. Okay. It shouldn't be said, let's suppose if I'm going to say you people that you people are very clever. So it means as a reference in my mind, I have the people which are very innocent. Okay, so that's why I said you clever. So if I'm going to say you that in my class I got a very small amount of the students, so it means in my mind there is another class which got a large number of students. Okay, so whenever anything that is said, it is always said with reference to some some reference point. Okay, you can't say that at one place you got 10 million electron. Okay, you can't say this is a very large amount. Maybe at other place there are the 10 billion electrons. Okay, so always keep remember whenever the E naught values of any electrode they are calculated. So they are being calculated when we made some reference point, and the reference point we made, that is the hydrogen electrode. Okay, so what we did, we made the hydrogen electrode and provided the standard conditions. So this is the beaker. We take the hydrogen gas in it through a tube. Okay, at 1 atm pressure, and we got the solution up here, H positive ion. H positive ion, they come from the acid. Okay, so the concentration of hydrogen ions, that is 1 mole per dm cube. Okay, and you know that hydrogen and hydrogen ion both are unable to conduct electron. So we put the platinum plate up here. So this is the platinum plate, and this is the platinum wire. Okay, and the temperature, that is, my dear, 298 Kelvin, which is called as the room temperature, 25 degrees Celsius. Okay, so under these conditions, what you did, you take the hydrogen gas, you got the hydrogen ions in the solution, okay, platinum plate, and you consider this as standard hydrogen electrode and consider its E naught value as 0.0. Okay, so you consider the E naught value as 0. Now, whenever you want to find out the E naught of any other thing, you are going to join it with the hydrogen electrode and put the voltmeter in between it. So voltmeter reading, okay, that is going to show you the E naught of cell. Okay, its E naught value, that is 0, and the E naught of the second electrode you can calculate it. Okay, so we are going to calculate that one. So standard hydrogen electrode is basically the hydrogen electrode under standard conditions, showing the E naught value of 0. That is called as the standard hydrogen electrode. Did you get it?
Yes, sir.
Okay. Now the next thing, that is SEP. Okay. What is the SEP? That is the standard electrode potential. So we got the standard electrode potential. S for standard, E for electrode, and the P word comes from potential. So standard electrode potential, that is called as the SEP. So whenever, my dear students, you want to find out the E naught of any half cell or electrode, what should you do? You should join it with the hydrogen electrode on one side, which we have considered as a standard hydrogen electrode. Its E naught value we have supposed that is 0. Okay. Now we join this standard hydrogen electrode with another electrode whose E naught value we have to calculate. Okay, so that is called as the test electrode. Okay, so now what I'm going to do, have a look up here. Its E naught value that is 0 for the hydrogen electrode. Okay, so now what should we do? This is the wire. Put a voltmeter up here. Now you people say to me, sir, we want to find out the E naught value of the zinc and we want to note it down on the data booklet. Okay, so now you should take the zinc rod like that. This is the zinc rod, and put that zinc rod into a solution containing the zinc ions like that. So zinc ions, and the concentration of zinc ions, my dear, that would be 1 mole per dm3. So the concentration of ions that should always be 1 mole per dm3. Now you should join the solution by putting a salt bridge up here. So this is the salt bridge. Okay, so this is the salt bridge. Okay. Now, my dear students, you know that in the reactivity series, if you see the hydrogen and zinc, zinc is always more reactive. I told you. So more reactive things that always become anode, and at anode the process of oxidation that will take place, which means loss of electron. So make up your mind. This one will become negative terminal, anode will become negative terminal, electron flow from negative to positive terminal. This is the positive terminal. Okay. So hydrogen that is less reactive, it will become cathode. Okay. So at cathode, the process of reduction that will take place, and reduction means gain of electron. Okay. So this is the voltmeter. This voltmeter has got a needle in the center. Up here negative is written, up here positive is written. So if the needle moves towards the negative thing, the value is negative. If the needle moves towards the positive thing, the value is positive. Let's suppose the voltmeter reading that is negative 1.13. So this is actually the E naught of cell. Okay. This is actually the E naught of cell. Okay. Now up here the process of oxidation is going to take place. So it means we have to find out the E naught of oxidation for that. And up here reduction. So it means we need the E naught of reduction for that. I told you that hydrogen E naught value that is always 0. Okay. This is we have supposed. Now what should we do, my dear? We should write the equation E naught of cell that is equal to E naught of oxidation plus E naught of reduction. So E naught of cell reading is this one minus 1.13. E naught of oxidation we have to find out, because we have to find out the value of E naught of zinc and zinc plus 2 ion, and we want to note it down in the data booklet first time. Okay, so now this one we have to find out, so we should write it as it is. The E naught of reduction, the hydrogen always got the value 0. So this is 0, my dear. So E naught of oxidation up here, that is negative 1.13. I told you earlier that the standard method of writing the E naught that is in reduction form. So if you get the E naught in oxidation form, you should change this one into reduction form. So change it into reduction form. So it would become positive 1.13. So it means now we should take the equation for reduction for the zinc. So zinc plus 2. So plus 2 electron, that is going to form zinc, and its E naught value you should note on the data booklet, that is positive 1.13 if you don't have the value of the data booklet. So if you want to find out the E naught of anything, on one side we should put the hydrogen electrode and consider its E naught value as 0. Okay, because this is the standard hydrogen electrode, its E naught value has been supposed as 0 as a reference point. The voltmeter reading is always the E naught of cell, of the whole cell. Okay, and the second electrode, if you want to find out its E naught, you can find it out by this formula. Okay, and by this one you can find out the E naught of unknown electrode. So if you want to define the SEP or standard electrode potential, so what is the definition of it? I'm going to write down its definition. SEP, the potential between standard hydrogen electrode. मेरी इक्वेशन कैसे बनाएंगे? कौन सी इक्वेशन पे एक बार कैसे बनाएंगे? रिडक्शन की इक्वेशन बना नहीं सकते हो. रिडक्शन का मतलब क्या होता है? गेन ऑफ इलेक्ट्रॉन. ये जिंक तो गेन ऑफ इलेक्ट्रॉन नहीं करेगा भाई, यही करेगा ना. Zinc plus 2 will gain electron to form zinc. So that is why this is the reduction. Data booklet, in the data booklet, the equations, they are always in reduction form. So if you get the answer in oxidation, so you should change it in reduction and make the reduction equation in which the gain of electron that would take place. We will practice this one, don't you worry. Okay, the potential between standard hydrogen electrode and the test electrode. Test electrode means whose E naught value has to be calculated. Standard conditions is called SEP, standard electrode potential. Okay, so this is the proper definition of the standard electrode potential. On one side, you should join the standard hydrogen electrode whose E naught value we have supposed as 0, and on the other side, you should put the electrode whose E naught value you have to calculate, which is called as the test electrode. And under these conditions, the potential between those two electrodes, that is called as the standard electrode potential. Did you get it? Fatma, Muskan, Uzair, Yahya, beta?
Yes, sir.
Did you get it?
Yes, sir.
Okay, guys, now we are going to start with some of the questions. Okay, so one by one, we are going to do those questions. First of all, the two questions I'm going to write it for you. Okay, and I will give you a chance to solve it by yourself. Okay, can I have this one? Okay, guys, now we are going to practice the past paper questions. They are very simple questions. Okay, so but before starting them, let's start the two questions. I'm going to make it for you. The first question: what is the E naught of cell if I2 and I minus electrode is coupled. Coupled means joined with Ag and Ag positive electrode. Okay, so this is the first question. The second question: what is the E naught of unknown electrode if it is joined with Cu and Cu plus 2 electrode and the E naught of cell is 2.14 volt and unknown electrode act as negative terminal of battery. Okay, guys, so these are the two questions. So I'm going to give you 3 minutes for this question. So I want every one of you should try for this one. Okay, doesn't matter, beta, if you are unable to solve it, doesn't matter. But please do try it. I'm telling you a method. In the data booklet, you should open the E naught values equations and find out the equation in which I2 and I minus is present. Write down that equation, write down its E naught value. Then you have to find out an equation in which Ag and Ag positive are present. Write down that equation and write down its E naught. I told you the smaller E naught, okay, that is more reactive, would become anode, would become negative terminal, and oxidation would take place. So you have to reverse that smaller value of E naught. Okay, so whereas the bigger E naught value that would remain as it is, then find out the E naught of cell is equal to E naught of oxidation plus E naught of reduction. So when you reverse the small E naught value equation, it's E naught value that could also be reversed. Okay. So then put the values and you will find out the E naught of cell. Okay. And then do the second question. Do first of all this question, giving you 3 minutes for it. Okay, guys. So I'm going to do that question for you by two methods. This is the explanatory method. First of all, I2 and I minus. I'm going to write down an equation I2 plus 2 electron, that is going to form 2I minus. Anyone should tell me what is the E naught value for that? 0.54. 0.54. So plus 0.54. And if you take Ag positive, 0.2 plus electron, that is going to form Ag, so that is plus 0.80. Okay, so now out of these two equations, this is the smallest value. So the smallest value that could be reversed, so it could be reversed. So we should reverse this equation. Okay, so I'm going to reverse that equation. So 2I minus, that is going to form I2 plus 2 electron, and its value would also be reversed, negative. Now you should do E naught of cell, that is equal to E naught of oxidation plus E naught of reduction. So if you look up here, this one is oxidation because loss of electron is taking place up here. So this is the E naught of oxidation now. Okay, and this is the E naught of reduction now. Now put the values up here, negative 0.54 plus 0.80. If you solve it up, what you will get? Plus 0.26 volt. So this is the E naught of cell. So it means, my dear students, if the I2 and I minus and silver plus ions, a cell is made, so it will produce the voltage 0.26 volt. Did you get it? This is the explanatory method. If you want to do it fastly, I'm going to give you this method E naught of cell, that is equal to higher E naught minus lower E naught. Okay. So higher E naught value is 0.80 and minus lower E naught value, whatever was present in the data booklet. Don't take this one because I have reversed this one. So in the data booklet, it was given plus 0.54 plus 0.54. So if you solve it up, my dear, minus 0.54, so it is again 0.26 volts. So you can do it like that as well. So you can use any of the formula, but this is more explanation. Okay, by that you can at least get this is more reactive, so it would become negative terminal. This one would become positive terminal. Electron flow from negative to positive terminal. So always keep remember, if you got the two equations with different E naught value, so the smaller E naught value is more reactive. It would become anode, and it would become negative terminal, and electron flow from the negative to positive terminal. Okay. Now move towards the next question. Question number 2. I'm going to give you 4 minutes for it. So let's start with this question now. The question is saying, what is the E naught of unknown electrode? So it means you got some unknown electrode. Okay, this is the unknown electrode. Its E naught value you have to calculate. Okay, if it is joined with Cu and Cu plus 2, so let's take the value from data booklet. Cu plus 2 electron is going to form Cu. So you only have to choose the equation from the data booklet in which Cu0 and Cu plus 2 are present. There are many equations in which Cu plus 2 and Cu plus 1 are present. In some equations, Cu plus 1 and Cu is present. So you only have to choose in which Cu and Cu plus 2 is present. Okay. So this equation, my dear, is this one, and its value, that is E naught value, that is 0.34. Is it? Yes. Okay. 0.34. Okay. Now the next part we are going to read. He's saying the E naught of cell is this one. So he has given us the E naught of cell, which is 2.14 volt. The next thing he is saying, unknown electrode act as a negative terminal. So it means this is the negative terminal, this is the positive terminal. So it means negative terminal to positive terminal, electron would flow. So this is more reactive. Keep remember that. This is the more reactive thing. Okay, and at more reactive thing, it would become anode, and at anode the process of oxidation would take place. So it means its value, that is basically E naught of oxidation. Okay, and its value we use as E naught of reduction. So this is already E naught of reduction. Now what should we do? We should write the formula E naught of oxidation plus E naught of reduction is equal to E naught of cell. E naught of cell has got this value 2.14. E naught of oxidation you have to find out. So write it as it is, E naught of oxidation plus E naught of reduction. It has got 0.34. Okay, so this one would come on the other side to be subtracted. Minus 0.34, that is E naught of oxidation. So if you just subtract it, what you will get, guys? 1.80. Guys, yes, 1.80 volt.
जी sir.
That is the E naught of oxidation. I told you the standard method of writing the E naught is always in reduction form. So change this one in reduction form. So it would become minus 1.80. So it means that E naught value for this unknown electrode, that is minus 1.80. So this is your answer. Did you get it? Fatma?
Yes sir.
Khan? Yeah.
Yes, sir.
Yes. Okay, guys. So you have to do the same question. And what I'm going to do, I'm going to change the values up here. I'm writing up here minus 1.49. And here I'm going to write Ag positive, not Ag positive. I'm going to write something else up here. Cl2 and Cl minus. Now do the same question again.